This is Teach Me IGCSE, and today we're doing Edexcel IGCSE June 2023 Physics Paper 2. So question 1, a pencil has a weight of 0.16 newtons. What is the mass of the pencil? So weight is equal to mg, so mass is equal to weight over g. So if you put that in your calculator, so 0.16 over 10, we will get 0.016, and that will be in kilograms. So our answers here are in grams, so we need to multiply the answer by 1000, so that will give us 16 grams. So B is the answer. Next, the diagram shows a pencil with one end resting on a small block, and calculate the moment of the weight of the pencil about the pivot. Use the formula moment is equal to force multiplied by perpendicular distance from the pivot. So weight is 0.16, and that is our force in this case, and the perpendicular distance from the pivot, as we see, is 3.7 centimeters. So since moment, the unit of the moment here is Newton centimeters, we don't have to convert the distance from centimeters to meters. So we just do 0.16 multiplied by 3.7, and that gives us 0.592 Newton centimeters. Next, state the moment of the force F. Now we assume the pencil is in equilibrium, so anti-clockwise moment is equal to clockwise moment. So we already found the anti-clockwise moment, so the clockwise moment should be the same, so our answer will also be 0.592 Newton centimeters. Show that the force F is 0.08 newtons. So we need to use the formula moment equals to force times perpendicular distance from the pivot again. But here force is equal to moment over perpendicular distance. Moment stays the same, so it's 0.592 divided by the perpendicular distance from the pivot to force F, which is 7.4 centimeters. So we do 0.592 divided by 7.4, and we get 0.08, which proves that force F is 0.08 newtons. Question 2, a solid bar of chocolate is taken from a refrigerator. The temperature of the chocolate bar is 5 degrees. Describe the arrangement and motion of the particles inside the chocolate bar. So we know that when the chocolate is at 5 degrees Celsius, it's in solid state, which means the particles are arranged in fixed position. So arranged in fixed position. And in a solid, the particles have a vibrating motion. And those are the descriptions which we use to describe particles within a solid object. Next, the chocolate is heated at a constant rate until the temperature reaches 45 degrees Celsius. The chocolate has a melting point of 32 and a boiling point of 55. Describe the motion of particles when chocolate is at a temperature of 45 degrees Celsius. So we're given the melting point and the boiling point here. Something that you should remember is that when the temperature is below the melting point, the object is in solid state. When the temperature is between the melting point and the boiling point, it's in a liquid state. And when the temperature is greater than the boiling point, then it's in gas state. So here 45 is between 32 and 55. So this is in liquid state. The chocolate is in liquid state. So compared to before, we can say that the particles in the chocolate are no longer in fixed position. No longer in fixed position. And what happens to the motion of the particles? They move randomly. Alright. Which of these is used to measure the temperature of the chocolate? A, balance, B, ruler, C, stopwatch, D, thermometer. So to measure the temperature of the chocolate in IGCSE, thermometer is your only choice. And last part to this question, we need to sketch a graph of how the temperature of the chocolate changes with time when it is heated from 5 degrees to 45 degrees. So at the end of the graph, our temperature has to reach 45. And we already know that our melting point is 32 and our boiling point is 55. So from 5, we can draw a direct straight line until 32 and just estimate approximately the time, use up most of the graph. And we have to draw a straight line from 32 here like this to show that it is changing state. And then we draw another direct line up to 45, which is our boiling point. And that's the graph. Question 3, the diagram shows the inside of an oscilloscope. The grid is connected to the positive terminal of a high voltage power supply, and explain in terms of the movement of particles how the grid has become positively charged. Well, electrons from the grid is transferred to the stream of electrons. The grid loses electrons, which leaves it positively charged, as there are less electrons than before. State the formula linking kinetic energy, mass, and speed. So this one you should remember. So Ke, kinetic energy, is equal to half mv squared. So half mass times v squared. Calculate the speed of an electron when it has 1.3 times 10 to the power of minus 15 joules of kinetic energy. So we rearrange the formula. V squared is equal to 2Ke over m, and V is the root of 2Ke over m. And if we plug it in, we have root of 2 times 1.3 times 10 to the power of minus 15. All this over the mass, which is 9.1 times 10 to the power of minus 31. And our V is going to be 5.3 times 10 to the power of 7 meters per second. Next, explain why the electrons in the stream move apart from each other. Well, as we know, opposite charges attract and like charges repel. And the electrons, they all have the same charge. They're all negatively charged. So they repel from each other, moving them apart. And then we have this circular pattern. Use a scale to determine the radius of the circle. So each square shown here represents 1 centimeter. If we take from the center to the side of the circle, we see that it's represented by 2.5 square sides, which means 1 centimeter plus 1 plus 0.5. That gives us a 2.5 centimeter radius. The time taken for the electrons to complete one orbit of the circle is 24 milliseconds, and calculate the orbital speed of the electrons. So we're giving the formula 2 pi times orbital radius over time period is the orbital speed. And we need to change the orbital radius into 2.5 times 10 to the power of minus 2 meters, as we need the speed in meters per second. So 2 pi times 0.025 over the time period, which is 24 milliseconds. So 24 milliseconds is 0.024 seconds. And we put that into our calculator and we find the speed to be 6.544 meters per second. So 6.5 meters per second is our orbital speed. Question 4, the diagram shows two birds just before bird X catches a smaller bird Y. Show that the momentum of bird X is about 5 kilograms meter per second. So momentum is calculated by mass multiplied by velocity. So here we just do 0.41 times 13 and we get 5.33. So that's around 5 kilogram meters per second. B, calculate the total momentum of the birds just before bird X catches Y. The momentum of bird Y just before it is called is 0.15. So we just add our previous answer with this one. So 5.33 plus 0.15, and the total momentum is 5.48 kilogram meter per second. State the total momentum of the birds just after bird X has called bird Y. Well, because of conservation of momentum, total momentum before is equal to total momentum after, so momentum stays the same. So it is still 5.48 kilogram meters per second. Bird Y has a mass of 0.17 kilograms. Calculate the velocity of the birds just after bird X has called bird Y. So our total mass is now 0.41 plus 0.17, which is bird X plus bird Y, and that is 0.58 kilograms. And our total momentum we found earlier is 5.48. So using the same formula, momentum over mass is our velocity. So we do 5.48 over 0.58, which is our total mass, and we get 9.45 meters per second as our velocity.